Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 22 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1028. Recover a tree from pre-order traversal. Okay, we have to recover a tree from pre-order traversal. Okay, so pre-order traversal is given to us, right? So what is pre-order traversal? So in pre-order traversal, first we visit mid node, then we visit left, and then we visit right. Okay, so this is nothing but my pre-order traversal. Okay, mid, or you can say root. Okay, and after root we are going to traverse the left side part of the tree, and then after that we are going to traverse the right side part of the tree. Okay, so now let's read the problem statement first. We run a pre-order DFS on the root of a binary tree. Okay. At each node in this traversal, we output D dashes. Okay. Where D is the depth of this node. Okay. Then we output the value of this node. Okay. So first D dashes are there. Okay. And this D dash is nothing but the depth of this node. And then we are going to output the value of this node. Okay. If the depth of node is D, the depth of its immediate child is D plus 1. Right. The depth of the root node is 0. Okay, so root node depth is 0. Okay, and if a node has only one child, that child is granted to be the left child. Okay, so we have given the output traversal of this traversal. Okay, so output is given to us in the starting itself. Okay, we have given the output traversal of this traversal. We have to recover the tree. Okay, and return its root. All right, so now let's understand this problem statement with an example here. Okay, so see here, example number 1. All right, so here this is traversal given to us. Okay, this one string given to us. Okay, so in this traversal, this is nothing but my pre-order traversal. Okay, so first we are covering mid, then we are covering the left part of tree, then we are covering the right part of tree. Okay, so in this string here, first we have one. Okay, then one dash. Okay, so this one is going to be my root, right? And this root is at 0 depth, right? And these 2 and 5 are at 1 depth. Okay, and these 3 4 6 7 are at 2 depth. All right, so this is my output, actually this diagram. Okay, but here see the traversal. Okay, how we are getting this output first. From this, how I'm getting this output. Okay, so here if you see, first 1. Okay, so we are writing 1. Okay, then after 1 we have 2. Okay, mid, I covered mid, right? Now I'm going to cover the left part. Okay, so I move to the left. So this is 2 at depth 1, so 1 dash, right? And here I'm writing 2. Okay, so still I'm covering the left part. Okay, so 2 here, again I go to the left part. Okay, because for this subtree, this is going to be left, this is going to be mid, and this is going to be right. Okay, right? So again we have to go to this part. Okay, so 3 is at a depth 2. Okay, so 2 dashes, right? And then we are 3. Okay, all right, done. Then for, if you just see this particular tree, okay, so this is mid and this is left and right. Okay, so we have covered mid for this, we have covered left for this, now we have to cover right for this. Okay, so 4 is at depth 2, right? So here I'm going to write 4 again with the depth 2. Okay, so now this complete tree is covered. Okay, now here if you see, this complete part is my left, this is my mid. Okay, so now I have to traverse this right side part. Okay, right? So now here, now I move to the right side part. Okay, so let me just remove it quickly. Okay, so now here this 5. Okay, so this 5 I'm going to write first. Okay, for this particular subtree, this is my mid, so mid I'm going to write. Okay, and this 5 is at 1 depth 1. Okay, so 1 dash, and then we have 5. Okay, then for this subtree, okay, this one, so be 6, we have to write 6 now. Okay, mid, left and right. Okay, this is a traversal, so 6 is at depth 2, so 2 dash is 6, and then we are going to write 7. Okay, so in this way we have completed this complete tree. Okay, so this, see this is the input given to us, right? This is the input given to us, 1 dash 2, then again 2 dashes 3, then 2 dashes 4, then 1 dash 5, then 2 dash 6, and then 2 dash 7. Okay, so I hope that you guys are clear how this input is given to us. Okay, now from this input we have to make this output. Okay, so now how we are going to do that? Okay, so this is what we need to solve. Okay, using this output which is given to us as input. Okay, using this input we are going to get this output. Okay, and how? Okay, so what I'm going to do here, let's write this string. Okay, so what is this string here? uh, 1, and then a dash, then 2, then we have 2 dashes, then we have 3 here, then we have total 2 dashes again, then we have 4 here, then 1 dash, and we have 5 here, then we have 2 dashes and 6 here, and then we have 2 dashes and 7 here. Okay, this is string given to us, right? So here let me just write the indexes for all that. Okay, 0 1 2 3 4 5 6 7 8 9, then 5 is at 10 index, this is at 11 12, and this 6 is at 13 index, and 14 15 16. Okay, at 16 index this we have. Okay, so here this is 11, this is 12, right? This is 14, and this is nothing but 15. Okay, all right, so I have written the indexes here. Okay, so what I'm going to do now, I'm going to run one loop, okay, over this. So here I will set my I at this particular position. Okay, done. All right, so now here first what I will check here, uh, here I is not out of bound yet, right? So I will check that condition, my I should be less than the traversal dot length. Okay, if my I is greater than equal to traversal dot length, that is 17 or more, then we have to just return, right? Then we don't have to do anything further, right? So right now my I is at this position. Okay, so from this position onwards I will check the number of dashes. Okay, from this, but at this particular position we have a number, no dash, so number of dashes we have here 0. Okay, number of dashes 0. Okay, done. So now number of dashes is 0, right? And in the starting I will create one variable depth. Okay, in the starting I will create one variable depth. Okay, and I'm going to set it to 0. Okay, so depth is also 0 and number of dashes is also 0. Okay, so that simply means that I am going to be here, okay, at my root node only. All right, so now done. Okay, here only, right? Number of dashes is equal to the number of depth. Okay, here my eye is at this particular position. I am checking the number of dashes starting from this. So this is a number, so no dashes. My dash is 0, my depth is also 0. All right, so now what I'm going to do here, I'm going to move further. Okay, so now I will check the number starting from this index. So here we have 1. Okay, we can have a number like this 423 here itself in the starting, so we have to take that complete number, right, in the first step. Okay, so here we have just 1, so done. Okay, so here this is done, number is 1, so I am going to add this 1. Okay, add this 1. Okay, this is right now a character, I will change it to a number, and I will create one node. Okay, and in that node I will pass this value 1. Okay, so here I am adding 1 here, right? Done. Then my eye is going to move further. All right, my eye moves further. Okay, so now eye moves further, and here we have already added 1. Okay, so now for this one we have to check the left part and we have to check the right part for this one. Okay, we have to check two things now for this one. Okay, left part and right part. Okay, so let me just move it a little bit downward. Okay, so yeah, so here now first you know that in the traversal we have input like this, mid, left and right. So I calculate this mid. Okay, this one I have calculated this. Okay, so now I have to check for this part first. Okay, this part first. So starting from here I, okay, so number of dashes here 1. Okay, so number of dashes 1, so here I will just update that my number of dashes is 1 now. Okay, and this is at depth 0 and these two are at depth 1. So now my current depth is 1, right? Here at this level my depth is 1, right? My depth is 1 at this particular level. So now again number of dashes and depth is matching, right? So if number of dashes and depth is matching, that simply means that we can get the value at this particular position. Okay, so now what I'm going to do, I'm going to move my eye further. Okay, So I'm going to move my eye to the next number. Okay, so I have this number right here, so my eye is moved here. Okay, so now here, from here I will check the value. Value is 2. Okay, so 2 is the value, so I'm going to fill 2 here. Done. Okay, then my eye is going to move further. Eye is moving to this particular position. Okay, I moves here. All right, so now here I fill this 2 values. So again, for this 2 we have to check left part and right part. Okay, so this left and right is at depth 2 now. Okay, this is nothing but depth. Okay, this is nothing but depth. I'm writing depth here. Okay, depth 2. Okay, so here I, starting from here, number of dashes, number of dashes 2. Okay, so here number of dashes I will change it to 2. Okay, number of dashes 2. I am moving my eye forward, my eye moves here, and now number of dashes and depth is 2. Okay, so I'm at this particular node right now. Okay, from here I move to here. So for this I have to fill value now. So at this level we have depth is 2, and here number of dashes 2. That simply means that I have to fill this value, right? First we are filling left child always, right? So from here I will get the node value. Okay, this node value, so node value is going to be 3, so I'm going to fill 3 here. Okay, so I'm filling 3 here. Done. Now my eye is going to move further. Okay, here my eye reaches here. Now again we have to check 3 is left and right. Okay, so this is nothing but add my depth 3. Okay, so here now see carefully here what is going to happen. Okay, I will count the number of dashes. Number of dashes is 2 here. Okay, number of dashes 2 here. So my eye is going to move forward. Here my eye reaches here. Okay, but now at this number of dashes 2, but my depth is 3. So that simply means that for this node, okay, this node is going to return null to me. Okay, so here this is null. Okay, nothing, null. Okay, so we are not going to fill this. All right, now this is done. Okay, so we already know the mid. We know that in the left we are not going to fill this value. Now check in the right, we can fill this value, this 4. No, we can't fill because this node is also at depth 3 and number of dashes 2. Okay, so dash number of dashes not matching with the depth. Okay, so we are not going to fill this. So from here also null is there. Okay, so done. Okay, so this is also going to return null. Okay, so this there is no node, right? This simply means no node. So from this downwards we are just returning null. Okay, there is nothing here. Okay, now I know this mid, I know this left. Now I have to fill the value in the right of this. Okay, so here we can fill the value. Okay, so here depth is 2 and number of dashes 2 and node value now 4, so I'm going to fill 4 here. So I have filled 4 here. Okay, done. Clear? Okay, so once this is done, now my eye is going to move forward. My eye reaches here. So here number of dashes 1. Okay, so number of dashes 1, number of dashes 1. Okay, so here I'm going to check first 4 left and right. So definitely we are not going to fill the value because number of dashes 1 and here depth is 3, so we are not going to fill this, so it is going to return null. And I'm going to check the right part whether I can fill the value here. So this is also going to return null. Okay, so now this 2 is also done, complete 2 3 4. Okay, now I'm going to check the once left is done, once right. Okay, so here depth is 1, here depth is 1. Okay, so here I'm going to fill 5. Okay, 5. So now my eye is going to move further. Okay, so now my eye is going to reach to this. So here I will check my 2 dashes are there, so number of dashes 2. Okay, so first we have to check, fill the left part of this 5, right? So number of dashes 2. Okay, and this is also at depth 2, so we are just going to fill this 6 here. Okay, then my eye is going to move further. Okay, I is going to move further here. So 6 left and right we are not going to fill because they are at level 3, but here the number of dashes for 7, okay, is 2 only, right? So we are not going to fill, so we are going to fill 7 here. So in the end you will get this tree now, 1 2 5 3 4 6 7. Okay, that is going to be your output. Okay, so from downwards here we are just returning none, nothing here. Okay, so this is going to be my output. Okay, so that's what, and then my I going to out of bound. So that's it, your problem is done, right? So easy, right? Same way here. So now I will just do it quickly. Okay, okay, so first initially depth 0, so I see that number of dashes is 0 here, right? So we are going to fill 1 here. Okay, now I have to fill the left and right part of this 1. Okay, so left part here, the number of dashes 1, so I'm going to fill this 2. Okay, then I have to check for the left and right of this 2. So here 2 dashes, 2 dashes means that this I can fill with 3, and here we have 3 dashes. Okay, so 3 dashes simply means that I can fill here. Okay, this 4, this 4 with this one. Okay, done, done here 4. Okay, then we have 5 at 1 dash, so at 1, so this is only a level. Okay, with the depth 1, so 5 here. Then 6 2, so here I can fill 6. Okay, then 7 3, so 7 3, so first we have to fill the left part now here 7. Okay, so this is going to be here null null. Okay, so if you see the output, so now 1, okay, then 2, right, and then we have 5 here, then 3. Now we have to write null here, right, because we have to cover complete until here now. So 3 null, 6 null, 4 null, 7. Okay, and there is no need to write this until here, only until 7 only we have to fill now, right, until 7 only, right? So after that there is nothing, so no need to write. But in between, if this is null now, so we have to write that, because we are filling the values like this. Okay, 1 2 5, 3 null, 6 null, 4 null, 7. That's it. Okay, so now see here 1. So initially 1 I'm going to fill here, then I will check left and right. Okay, so here it is saying 401 at 1 left. So 401 is a complete number I have to write here. Okay, it's not like just 4. So I have to find out this complete number 401. Okay, then 401 I will check left and right. So here 349 is at 2 left. Okay, so here I can write 349, 349. Okay, then this 90 is at 0 1 2 3 left. Okay, so this is at 1 left, this is 2 left, and this is 3 left. So here I have to write 90. Okay, so now after that 90, this 88 at 2 left, so 88 I have to write here. Okay, so now here here what we are returning, we are returning 1401 null, then 349 88. Okay, done, and then we are returning 90 here. That's it. Okay, that's it. So this is how we need to solve this problem. Okay, now let's write the code. So same story, I'm going to write the same code whatever I explained here. Okay, so now let's get started with the coding part. Okay, so my index. Okay, so let's do one thing here. Let's create the index here under this class only, right? Because I'm not going to pass this I to any helper method. Okay, I will just create a globally. Okay, so static int index I'm going to set, or you can say I is equal to 0. All right, and here in this I is equal to 0, right, in the starting. And now here I'm just going to return the helper method. Okay, and in the helper method I'm just going to pass this string traversal, and I will just pass 0. 0 is nothing but my current depth. Okay, done. Now here let's write this method. Okay, so private tree node helper. Okay, so inside this just pass the string traversal, and then after that just pass the depth. Okay, right. So now here inside this one base condition, that if your index becomes greater than or equal to this traversal dot length, then what you need to do, okay, then your I goes out of bound now, so simply return null from here. Okay, one base condition, right? Now we have to first what we are doing, we are counting the number of dashes, right? So let's count the number of dashes. So int dash count. Okay, so dash count, let's say initially is 0. Okay, then just run one loop. Okay, and here while here I plus dash count. Okay, dash count. Okay, if I plus dash is less than traversal dot length. Okay, and traversal dot character at index I. Okay, plus dash count. Okay, if this is equal to 0, or this is like this, okay, then only we have to count the number of dashes now, right? So here I will just increment the dash count. Okay, so right now I is 0, right, dash is 0, so at 0 I'm checking 0 is less than traversal dot length, yeah, true, and traversal dot character at 0 is not equal to this. Okay, so dash count is still 0. Okay, until here the dash count is still 0 only. All right. Okay, now once this is done, okay, so here once this is done, then after that what we need to do, after that we have to count, we have to check if the number of dashes does not match the current depth. Okay, so if it doesn't match, then what we are doing, we are just simply returning null. Okay, so here if dash is not equal to the depth, okay, so in that case also we have to return null. Okay, so I was returning null, I've shown you that, right? Done. Okay, then once we count the number of dashes now, so we have to move to the next number. Okay, so we have to move index past the dashes. Okay, so I is equal to I plus dash. Okay, done. So now we have to extract the node value. Okay, so node value, it may be just 1 or it may be 1 2 3. Okay, so we have to find out the complete number. Okay, until we encounter any dash. All right, so here we're going to run one while loop. While I is less than traversal dot length, right, and we have a digit. Okay, we have character dot, if character is digit. Okay, if character is digit, okay, where, at which position, at traversal dot char at I. Okay, so let me just copy this now. Here character is digit at traversal dot char at the index I. Okay, so if it is digit, all right, if it is digit, then in that case only, okay, in that case only we have to update the value. Okay, so value is equal to, all right, so here create one variable value, int value, and set it to 0 initially. So value is equal to, I have to form the complete number now. So value is equal to value into 10 plus, and here traversal dot char at that particular index. Okay, and okay, traversal dot char at that particular index, and I have to subtract 0 from it. Okay, so here minus 0. All right, done. And after that we have to increment the I value, so I am simply going to write here I plus plus. Okay, I move to the next index. Okay, so I have to find out complete. Okay, so see here 401. Okay, so let's suppose my I is at this, so first we have 4, right, so value is 0 initially, right, 0 into 10 plus 4, I'm going to get 4. Okay, then next character is also a number, right, it is digit. Okay, so now here next time 4 into 10 plus I'm going to add this 0, so I will get 40. Okay, next time 40 into 10 plus 1, I will get 401. Okay, this is how it's working, right? So this is a simple logic that I'm doing here. Okay, I am moving every time, right? So once we get this, okay, so that simply means that I have got the value for the current node. Okay, so we have to create a current node first, tree node, and here new tree node, and here we have to just write a value. All right, done. And then we get the value. Then I told you every time what we are doing after writing this, after creating this one. Okay, then I will check for the left part, and then I will check for the right part. Then once I get the value for this one, then for this one first I need to check the left, and then we have to check the right. Then for this we have to check the left, then we have to check the right. Okay, so same logic I'm going to write. So that is nothing but recursively I'm going to build the left and right subtrees. So here first node dot left. Okay, so in the node dot left I'm just going to call this helper method again, and in the helper method I'm just going to pass traversal, and now here depth plus 1. Okay, so depth is incrementing, right, if I'm moving one step downwards. Okay, right, and same way we have to check for the right side. Okay, so node dot right, once I solve the left part, then I will solve the right part. Okay, and in the end once all this is done, I'm just going to simply return what node. That's it. Okay, let's run the code and see if the code issue will try to fix that. So all the test cases has been accepted, right? Nice. So only 30 lines of code, right? So let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.